Amazon Elastic Container Service, Amazon ECS, is a fully managed container orchestration service that helps you easily deploy, manage, and scale containerized applications. Hello, my name is Alex. I am a senior software engineer specializing in AWS development. We are going to talk about AWS ECS. We will cover what AWS Elastic Container Service is. We will take a look at key features and architecture overview. We will explore AWS ECS layers and ECS application lifecycle, and we are going to have a demo. AWS ECS is a fully managed service for container orchestration, making it simple to run, stop, and manage Docker containers on a cluster. It seamlessly integrates with other AWS services, including EC2, Fargate, IAM, and CloudWatch, providing a comprehensive solution for managing containerized applications. AWS ECS offers flexible hosting options, allowing you to run containers on EC2 instances or using the serverless AWS Fargate. It is deeply integrated with other AWS services, providing seamless interoperability. The service supports automatic scaling of containerized applications, ensuring that they can handle varying loads efficiently. With built-in security features, ECS enables fine-grained permission management through IAM roles. Additionally, it integrates with AWS Cloud Map, simplifying service discovery within your applications. Let's take a look at ECS architecture. AWS ECS organizes tasks and services into clusters, which act as logical groupings. A task represents a running instance of a task definition similar to a Docker container, while task definitions serve as blueprints for your applications, detailing container settings, images, and ports. Services manage the desired number of tasks, ensuring they continue running by rescheduling any that fail. ECS supports two launch types: EC2, where you manage the underlying instances, and Fargate, a serverless option that handles infrastructure management for you. Let's now zoom out a little bit and look at AWS ECS layers. There are three layers: capacity, controller, and provisioning. Amazon ECS capacity refers to the infrastructure where your containers run, offering several options. You can use Amazon EC2 instances in the AWS cloud, where you select the instance type, quantity, and manage the capacity yourself. Alternatively, you can opt for the serverless AWS Fargate, a pay-as-you-go compute engine that requires no server management, capacity planning, or container workload isolation. Alternatively, you can opt for the serverless AWS Fargate, a pay-as-you-go compute engine that requires no server management, capacity planning, or container workload isolation. For on-premises environments, Amazon ECS Anywhere allows you to register external instances such as virtual machines or servers to your ECS cluster. This capacity can be deployed across various AWS resources, including availability zones, local zones, wavelength zones, AWS regions, and AWS outposts. The controller layer deploys and manages your applications that run on the containers through Amazon ECS Scheduler. Finally, Amazon ECS can be provisioned through various tools. The AWS Management Console offers a web interface for managing ECS resources, while the AWS Command Line Interface, or CLI, provides command line access across multiple platforms. AWS SDK, or software development kits, offer language-specific APIs that handle connection details such as signatures and error handling. For developers, Copilot is an open-source tool that simplifies building, releasing, and operating containerized applications on ECS. Additionally, the AWS Cloud Development Kit, or CDK, allows you to model and provision cloud resources using familiar programming languages, deploying them through AWS CloudFormation. In our demo, for simplicity, we're going to be using the AWS Management Console. Now let's take a look at AWS ECS application lifecycle. To run applications on Amazon ECS, they must be containerized, meaning they should be packaged with all necessary code, runtime, tools, and libraries. Containers are built from images typically created using Docker file, which outlines the build instructions. These images are stored in a registry like Amazon ECR. Once an image is ready, you create an Amazon ECS test definition, a JSON blueprint that specifies the container details or operating system parameters and other configurations. You can then deploy the test definition as a task or service within a cluster, which is a logical grouping of tasks or services on registered infrastructure. The ECS service maintains the desired number of tasks by automatically replacing any failed tasks. The container agent on each instance with a cluster communicates with ECS to manage and monitor tasks. Post-deployment tools like CloudWatch and runtime monitoring can be used to track the performance of your applications. Now, with the AWS ECS theory out of the way, let's jump into the demo and check how it looks in the real world. But before we do that, if you are enjoying this video, please like and subscribe to our channel to help YouTube recommend it to more viewers. I am in AWS console. Let's go to Elastic Container Registry. This registry has a repository remix indie stack, and this repository has an image. I created this image from remix indie stack right here, and basically before I built it, I made a couple of changes. So let me switch to VS Code. Right here in the Docker file, I updated the env port to be 80 instead of 8080, so we don't have to drag it along. Then I went to session.server.cs file and I commented out secure attribute in a cookie object. Since we're not going to be using SSL, right, HTTPS, we're going to be using HTTP. The secure attribute won't allow us to set cookies, right, because it will require the HTTPS. Let's go back to AWS, and in this registry in a repository, we can copy the image URI. Now let's go to Elastic Container Service, and the first thing that we need to do is to create a cluster. So we're going to click on Create Cluster, and the cluster name will be Remix Indie Cluster. We're going to select AWS Fargate serverless infrastructure, and we're going to leave everything else the same. So we can just hit Create Cluster. It may take a little bit to create a cluster. And while the cluster is being created, let's go ahead and create the test definition, which will be the blueprint for our container. Let's click on Create New Test Definition, and we'll select Create New Test Definition. And in a test definition family, we can call it Remix Indie Stack Task. Also, as an infrastructure requirements, we're going to use AWS Fargate. Operating system will just leave Linux. In the task size, you can select CPU and memory, and Fargate will charge you depending on this CPU and memory, and for one CPU it charges you about 4 cents. So the smaller container you're gonna have, the cheaper it's gonna be for you. So I'm just gonna opt for the smallest one, but obviously if you are deploying a enterprise level application, you just gonna selecting enough CPU and memory for your application to run. Let's go ahead and open right here task roles, and there are 2 task roles. One is called actually task role, and this task role is used when the task is running or your container is running. So if your app needs to connect to S3, for example, you're gonna have the role that will allow S3 connections. Task execution role is used when your container is spun up. So one of the permissions, for example, will be to go to ECR and pull your image. There's some other permissions, and you can take a look at them. But if you are not gonna have this task execution role because it's necessary, AWS will create it for you. In my case, I already have ECS task execution role, and it is already selected. Since we're using Fargate, the task placement right here is irrelevant because the Fargate will take care of placing your tasks. In the container section, we can define the container, and we can call it again Remix Indie Stack Container. And here we can paste the repository URI that we copied. Next, we have a container port. Usually it will be selected for you if you don't define it, but in our case, we know that the port we're going to be running on is 80. Sometimes you're going to be running on a port 3000 or 8080, so you're going to put it in. And the port name, you can just specify something like port 80. You can also specify additional port mappings, but in our case, the application only uses one port. Next, we have resource allocation limits. We're going to leave them the way they are. Next, we have environment variables, and those are runtime environment variables for the application. Since our application will be authenticating users, it actually does need an environment variable, and it's called session secret. We can put it right here as a key, and the value type, we're going to use value. The value from, you can select if you're pulling your values from a secrets manager or parameter store, and it's a better way of actually storing your environment variables. So usually you would want to prefer that. But in our case, for simplicity, we'll just select value, and then we're going to put the key value right here. You can also have an environment file, right? If you select that, you can actually specify your S3 bucket location where you can have your .env file. In that case, your ECS task execution role should also have access to S3. Next, we have logging, and we're going to be logging to Amazon CloudWatch, but you can also select other different destinations like Splunk, for example, Firelength, or S3. We're just going to leave everything the same. There are some other options here, like a restart policy or health check. The health check you will be using if you are putting a load balancer in front of your tasks. You can also specify container timeouts, but we just leave the default one. You can also specify your Docker configuration, like for example, put a different entry point command. There are also resource limits and Docker labels, but we're not going to enter anything in there. Next, we have storage, and we just will leave the things the way they are right here. And in the monitoring, we're going to also leave everything as it is. And tags, we're not going to add any tags. So let's go ahead and create the task definition. The task definition is created. Now let's go ahead and deploy it. So right here in the deploy, click create service, and we have a create service prompt. So, and our service is already placed in Remix Indie cluster because that's the only cluster we have. Next, we're going to be using capacity provider strategy. And we also have a capacity provider, either Fargate or Fargate Spot. If you choose Fargate Spot, you got to keep in mind that your task need to be interruptible, so your workload, right, can be restarted at any time and continue. So in our case, we're going to select Fargate. In the platform version, we're going to select latest. Next, we have a deployment configuration, and our deployment configuration is service. And in the service name, we're going to put Remix Indie Stack Service. Our service type will be replica, and here we're going to put desired tasks as one, but you can put 2, 3, 4 or more, but for that you'll need to have a load balancer to load balance your tasks. In our case, we're not going to have a load balancer, so we'll put as a desired task 1. Next, we're going to have a deployment options, and we're going to keep deployment options as they are. And we also have deployment failure detection, and we going to be using rollback on failure, which is default. Next section is a service connect, and you're going to be using service connect when you have multiple services and you're going to need to communicate with them. So when you turn on service connect, you're going to have either client or server side. The client connects to other services, and the client and server will connect to services, and other services may connect to them. So, but this setting is out of scope of this tutorial. So let's go ahead and roll it back, and we're now going to be using Service Connect. Next, we have a service discovery. This thing you're going to be using if you need to put your service discovery into the namespaces. Again, if you're going to be communicating with your services, you're going to be configuring the service discovery. Next, we have networking, and in the networking, you're going to choose your VPC, and for us, it's already selected, and the subnets. By default, it's going to try to deploy your service across multiple subnets. We have both public and private subnets, and right here you also can select a security group. We're going to be using an existing security group, but you can create a new security group. So in our case, I'm actually going to select Web Access Demo Security Group. This security group will allow access to my application on HTTP port 80. We're also going to have a public IP address turned on, so our instance is actually going to be placed into our public subnets, right? And not private subnets, because private subnets won't have a public IP address. But here we don't have to remove private subnets, because AWS will be smart enough to place our container in a public subnet, since we have public IP turned on. Next, we have a load balancing, and it is, again, optional. If you have a load balancer, you can use application or network load balancer to balance your containers. You also have a service auto-scaling. Again, when you're using load balancer, and depending on your load, you're going to put what's your minimum and maximum number of tasks. You're most likely going to be using target tracking. You're going to create a policy name, and that policy will be the value of your CPU, or usually memory. Since we don't have a load balancer, we're not going to be using service auto-scaling. Next, we have volume, but volume for our test definition cannot be configured, and we don't need it. And we also have tags, which you can tag your service if you like, but we're not going to be doing that. Let's click create. And our service deployment is in progress, so you can usually refresh here, and you can see that 0 tasks are running and the deployment is in progress. We'll just need to wait till the deployment is completed. And it looks like our deployment succeeded. We have completed right here. So we can go ahead and click on tasks. Right here, we have our task. We can select the task. And since we assigned the public IP address, right over here, we will have a public IP address here. And then we can click open address. And as you can see, we have our Indie Stack application running. So since we don't really have any users right now in the database, we cannot log in. However, we can sign up. So let me put my email address as alex@alex.com, and my password is password. Not exactly secure, but this will do for the demo. We can click create account, and the account is created. And you can click on view notes for alex@alex.com. There is no notes. We can click here, create a new note. We'll put new note. And in the body, we can type in, this is our new note. We can save it. And we do have a new note now. And as you can see, our application is pretty functional and is deployed on a container in AWS. I hope this introduction to AWS ECS has helped you understand the basics of container orchestration in the cloud. To deploy our container, we used an image that we previously pushed to Elastic Container Registry. If you would like to learn how to do it, please check out our video on ECR.